Good morning, afternoon, everybody. Thank you for joining today's training session on the basics and best practices of using Tecplot 360. This will be a useful guide for new and longtime users to review the basic capabilities of Tecplot 360. My name is Jared McGarry, and I'm one of the account managers here at Tecplot. I started with Tecplot as part of the technical support team, and I've had experience working with many of our customers. I will be joined by my colleagues, Brandon Markham, one of our product owners, and Jens Varkal, Senior Technical Consultant for our European office. And both of them will be assisting me in answering questions that come up during the demonstration. If you have questions after the webinar, you can reach out to us at support@tecplot.com. Before we begin the demonstration, I will say a few words about Tecplot, the company, and Tecplot 360, our main software. The company that became Tecplot was founded in 1981 by two Boeing aeronautical engineers who initially began with writing CFD codes, but they quickly realized that there was a real need for visualization of the results, and so they hired a developer to accomplish that, and that developer has stayed with Tecplot to this day. That was 40 years ago, and we are still going strong with over 47,000 customers worldwide and in multiple industries and disciplines. Tecplot 360 is known as the most complete desktop post-processing solution. It has the ability to render not only beautiful 3D plots, but also quantitative plots with line plotting and 2D plotting for detailed decision making. We are dedicated to saving you time, and we do this in several ways. By optimizing the way data processing is done in Tecplot 360, reducing the number of mouse clicks for common workflows, and by automating Tecplot 360 through macros and Python. We are also dedicated to solving the big problems in CFD, one of which is post-processing large, heterogeneous data sets. One of the most time-consuming parts of post-processing is loading data off the disk. The image here represents our SCL or sizzle file format, which helps you by loading less data, by waiting until you need to use the data to load it, using less RAM because less data is loaded at a time, and by performing workflows faster, saving your time in your work. Tecplot 360 is also a suite of tools, one of which is Tecplot Chorus, which allows you to analyze ensembles of data. For example, if you are doing design experiments, this tool will help you see the big picture in Tecplot Chorus and then filter down to the details as a companion to Tecplot 360, getting to the answers you need faster. Tecplot 360 also has a built-in macro language, as well as a full-featured Python API, which has opened the doors for more advanced automation and post-processing analysis. And that is a quick overview of what you get with Tecplot 360. Tecplot 360 itself for post-processing of data with a variety of plot types, Tecplot Chorus for comparing hundreds to thousands of simulation runs, PyTecplot for automation and analysis, and I should also mention that you get technical support, great technical support when you need it. Now let's get into the demonstration. So here is the agenda for today. I expect it to take close to 40 minutes. Then we'll do my best to answer your questions, and I'll have Brandon and Jens help me with the questions as well. So just to review, I'll do a quick tour of the Tecplot 360 user interface. I'll then show an example of loading a data set, then show how to explore that data set using the plot changes to the zones or regions of data, and then get into the derived objects, slices, isosurfaces, and streamlines. I'll then show how to calculate new quantities using the built-in calculate variables tool, part of the analyze toolset. I'll then show some data extraction over time. I'll then show some line plotting from that data extraction, and then I'll show how to export your results to images and videos. And then we'll close with questions. All right, so the dataset I will be using today is the flow over cylinder dataset, and this is actually saved in the Tecplot 360 Getting Started bundle. And if you want to, if you already have this downloaded, you can try and follow along, but we will record this webinar if you want to review it later as well. And you can download the Getting Started bundle, and there's a link for that on page 8 of the Getting Started guide, which is a document already included with the Tecplot 360 installation. All right, so let me switch over to Tecplot 360. Here we have what you should see when you open a fresh session of Tecplot 360. Let me give a quick tour of what we're working with here. So just below the software title at the top, we have the menu bar menus of note are the File drop-down menu, good for opening new layouts, loading data, and exporting our plot to images. View drop-down menu for shortcuts and view adjustments. The Data drop-down menu, which we'll use and come back to once we actually load in a data set. The Scripting drop-down menu, which I won't be using for this demonstration, but just for reference, this is where you can go to get started on recording a macro or a Python script to automate your work. The Analyze drop-down menu, which is something I'll close with near the end of the demonstration, which is useful for a deeper understanding and analysis of your data set. Just below the menu bars, we have the toolbars. We have the File toolbar for quick shortcuts for refreshing your layout, opening data sets. Next to that, we have the View toolbar for adjustments of the view of your plot. Next to that, we have the Data toolbar for changes to certain plot elements that we'll create in our plot. And next to that, we have the Insert toolbar for adding text, images, geometries, and then for drawing new frames in our data set. Below the toolbars on the left, we have the plot sidebar, which is more or less blank right now because we don't have a data set in it. But once we do load a data set, the plot will update with toggles for adjusting the view of the plot. Below that, we have the frames sidebar, which will show a list of the current frames that we have on our workspace, which is this gray background here. And then to the right of the workspace, we have our pages sidebar, which will list if we add any new pages. And pages are a way to have in the same instance of Tecplot 360 multiple workspaces. So if we add more pages, it refreshes this workspace and refreshes the number of frames. And having the pages sidebar allows us to click back and forth easily between those without having to open up a new session of Tecplot 360. I won't be using the pages sidebar for this demonstration, so I'll actually close the sidebar for now. And if I ever want to come back to that, I can go to the View drop-down menu and toggle that back on along with all the other sidebars. Below that, we have the Probe sidebar, which is useful for getting more detailed information about our plot. In the middle of the workspace, we have this welcome screen, which will show when you first launch Tecplot 360. And this has quick shortcuts for loading data sets and layouts, links to recent layouts that I've been using, links to the documentation that is part of the installation, and then if I have internet access, links to our online resources. And then in the bottom right, contact information for our technical support team, which I highly recommend contacting if you do have any questions while you are using Tecplot 360. All right, so let's load a data set. I can do that from the File, Load Data menu here. I can also click the Load Data button on the welcome screen in order to bring that up as well. So there's a couple different options if I want to bring up the Load Data dialog. And then for reference, we can also use the File drop-down menu to look at what some of the recent layouts are for our data set as well. So the welcome screen has shortcuts to everything that can be useful for bringing in our data set, but it's also repeated in the File drop-down menu and then saved elsewhere in our installation of Tecplot 360. All right, so I brought up the Load Data dialog. I've already navigated to where the data file is saved. And what I'm going to use is the overset cylinder.szplt file. So this is a subzone load on demand plot file. And for that, I need to use the Tecplot subzone data loader. But just to show you all the different data loaders available to us, I can click this drop down and you can see all of the loaders for all the different codes that can be brought into Tecplot 360. So I'll select the file, click open, and then my plot will update. The frame in the middle will update, showing the data set, and then the plot sidebar will update on the left. So let me show how to manipulate the plot view using the View toolbar. So the first tool I have is the Selector tool. I can click the surface of the cylinder in the middle. I can click the volumes by clicking these orange bounding boxes. I can click the axes in the upper right here, and I can click just next to the frame to bring up these anchor points to adjust the frame if I want to. Next to that, I have the Adjuster tool, which can do a lot of the same things, but can also do a couple additional changes to the plot that I'll show once we get to the XY line mapping. Next, I have the Magnify tool, where I can click and drag to zoom in on a specific region of the plot. I can hold Control on my keyboard and left click to zoom back out, or hold Control and F on my keyboard to do a view fit of all the surfaces in my plot. And for reference, that can be found in the View drop-down menu for that keyboard shortcut. Next, I have the Translate tool for translating the plot. And then we have several different rotation tools: standard rotation, rollerball, twist, and then these X, Y, Z axes locked rotations. And if I don't want to click through each of these different tools, I can also use mouse and keyboard shortcuts, which is what I'll be using most of for the demonstration as well. And that's if I hold right click and move my mouse, that'll translate the plot. Control and right click to rotate. Click and hold the middle mouse button to zoom in and out. And as I'm rotating this plot, you'll notice, and I already pointed out, we have these orange dotted lines. These are orange bounding boxes indicating that there are volume zones in our data set. I already know there's volume zones, and these are kind of getting in the way and distracting from the rest of the plot. So what I'm going to do is go to Options and toggle off Show Bounding Boxes so that those don't get in the way. But we'll come back to visualizing the data in the volume zones once we get to the derived objects later on. All right, now let's do a let's take a quick look at what the actual data set is that we've brought into Tecplot. So for that, I'll go to the Dataset Info, and open up the Dataset Information dialog. So you can see here I have the list of zones or regions of data on the left and the variables listed on our right. So just below the zone list, we have the information of each zone stated, the IJK indices, the zone type, and we also have the solution time and a time strand. So as I step through here, you'll notice the solution time stays the same for the first 14 zones, and then we'll change for the next one, and then the time strand will reset. So what this means is we have 14 volume zones per time step for this data set that we'll be visualizing for the rest of the simulation. And if I scroll down to the bottom of the list here, I also have these surface zones. These are the surface zones that are already visible for the cylinder. And if I step through these here, you'll see that I have 8 surface zones with the same solution time before that changes, but you also see that the time strand is consistent. And that's because of the way this data set is set up, we want to visualize all these surface zones of the cylinder at the same time, because each of these surfaces represents a different section that makes up the circumference of the cylinder. So we'll see that a little bit later once I show the edge zone layer, once I go through the plot sidebar. All right, actually, let me bring back Dataset Info, and I'll show the other tabs in the Dataset Info tab. Next one over gives us the dataset title, the location of the file or data files that I'm using, and then a breakdown of the total number of zones, variables, elements, and points in my dataset. And then the final tab is the aux data tab. And I won't be using this for this demonstration, but this is good for saving a single value or property to a specific zone or for the entire dataset. All right, now let's walk through the plot sidebar. So up at the top, we have the different plot views available to us: 3D Cartesian, 2D Cartesian, XY line, polar, and then sketch, which will appear when we first load in our dataset, or before we load in our dataset. I'll keep the plot type as 3D Cartesian for now. And then just below that, we have these snap to orientation views for quick view changes of our plot. And below that, we have these zone layer toggles. So the first one I'll show is the mesh. I can toggle this on and off here. I can also right-click the zone I'm interested in and toggle on the mesh from here. And you'll notice that as I toggle this one on, the plot sidebar toggle will automatically turn on as well. But if I click this on and off, the plot sidebar toggle stays on. And that's because this is a global toggle for all of the zones in the frame that I'm looking at here, whereas this from the right-click context menu is specific to the zone that I've selected. I can click this drop-down menu to change the mesh color if I want, but if I want to get even more detailed in refining it, I can double-click the zone to bring up the zone style dialog. I can also do that by clicking the zone style button just below the zone layer toggles. And from here, what I can do is I could change the mesh color. I could change the mesh color back if I wanted to. I could change the line pattern. I can change the line thickness. I can toggle the mesh on and off. And if I needed to, I can also control multiple zones by control left clicking, shift clicking, or hitting control A to select all zones in the data set. All right, the next zone layer toggle down that I'll show is the contour. So I'll toggle off the mesh in order to show that. So if I toggle on the contour, what this does is it floods the cylinder surface with a contour variable and a default color map. And if I want to change that, I can click this gear icon to open up the contour and multi-coloring details dialog. So if I change to something like row U, the color map will stay the same, but the contour levels will adjust for this new contour variable. You'll notice that it's the same color, and that's because we don't have any UV or W values at the cylinder surface. So those are all saved in the volume, so we'll revisit those when we are looking at the derived objects. So for this, I'll actually bring it back to that row or density variable. And if I want to change to any other or redefine a new contour group, I can redefine up to 8 of those. For this first contour group, I can change the existing levels. I can add it at specific values if I want, or I can reset for the total number of contour levels by doing a quick readjustment there. Just below the levels, I can adjust the color map that is currently being used if I want. I can click this drop down to change the color map altogether. Let's say I want to change to this sequential green color map. And then if I make adjustments to this, I could change the colors to the left or right of certain control points. I can add new control points, and any customizations I make to the color map, I can export for use in later layouts. And I can also import other custom color maps that I've used in the past. Then I can also change the distribution method, banded or continuous. I prefer banded so I can see the distinctions between the different contour levels. I can introduce a color cutoff above or below a certain value, and I can reverse the direction of the color map used. All right, so the next zone layer down is the shade, and this is actually toggled on by default. And this shows with a consistent color the surface, the cylinder surface, and I can change the color if I want to something different, make it stand out a little bit more if I want. But for this data set, this just gives us the shape, but we're getting more or less the same thing with the contour, so I'll keep the contour toggled on to use instead. The next zone layer down is the vector toggle, and as we saw with the contour, the UVW variables don't have any values on the surface, so I'm going to save using this for later once we do the derived object demonstration. Below this, I have the edge zone layer toggle. This shows us the boundaries of the zones in our data set, so we can see the full extent of the volume domain that those orange bounding boxes were trying to indicate when I first loaded the data set, and then we can also see the 8 sections that make up the circumference of the cylinder. So this is a good reference, but it can get in the way of the other visualizations I want to make, so I'm going to toggle this off for now as well. And then the last zone layer toggle is the scatter layer, and what this does, I'm going to zoom in just a little bit. This shows the location of the nodes in our data set. So I can toggle on the mesh to see how those are connected, and then if I want to make changes, I can go to the zone style scatter tab, and I can make changes to the symbol shape. For example, I can change the size down if I need to. And for this data set, it's just showing the location of the node. And it's not particularly useful for a data set like this. So I'm actually going to leave this toggled off as well. But just to point out, using the scatter zone layer can be really useful for 1D data, particularly particle data that you want to visualize, because you do have the option of sizing your scatter points by a specific variable in your data set, or even coloring by one of the contour groups, which points to a variable in our data set as well. So not useful for this data set, but it's good to keep in mind if you do have data like particle data that you want to visualize. All right, just below the zone layer toggles, we have this time tool, and this allows me to step through. Let me toggle off the mesh so we can see more clearly. This allows me to step through and see the different solution times in our data set. I can also click play, just have them stitch together and play all at once. And if I want to adjust that, I can click this gear icon to open up the time animation details dialog, and let's limit the animation speed so that when I play it, I can see it a little more clearly. So we'll come back to this dialog once I show how to export our plot, and that will be with this film strip icon, which allows us to export to a video file. So we'll close this for now, but we'll revisit that a little bit later. All right, the next thing I want to show is the probe tool, and this allows us to get more specific information about regions of our plot. So I can click this probe icon at the top here. I can also click it from the probe sidebar, and where the contour gives us information about the surface at a glance using these contour levels. If I use this probe tool, I get specific information at this exact point. So this gives us the values of the variables in our data set where I'm probing. So I can also toggle on the mesh, and the probe tool is still active, I can click and drag the middle mouse button and zoom in, still have the probe tool active, and this way I can probe at specific cells. I can control and left click to snap to the nearest node to get the exact values, because for this data set, the variables are saved at the node. The next tab down is for cell center values. So anywhere I click in a cell, I'm going to get these interpolated values, which are indicated by this asterisk. You can see this note at the bottom here reminding us that, and that's because the variables are saved at the node and so interpolated to the cell center for these values. The next tab down is the zone and cell info tab. This gives us information about at top the zone we are probing, and then at bottom the specific cell that we are probing. And the last tab is the face neighbor tab. This gives us information about cells that neighbor the cell we are probing at for a face neighbor connection. All right. So that's a quick tour of the toggles and plot style changes for the data as it is. What I'm going to go into next is showing the derived objects, which, as the name implies, are derived from the data set that we have, but add a little bit more visual information. So the first one I want to show is the slices tool. For this, I can click this button next to the slices toggle. It can also be found up in the data toolbar up here. If I left click, this places a slice that now cuts through the volume data in our data set. While I have the slice tool active, I can press X, Y, or Z on my keyboard to quickly adjust the orientation of the slice. I can also press A to change to an arbitrary slice. And this adds a arbitrary slice tool where I can click and drag this to adjust it. I can adjust the orientation of the slice to a custom direction, and I can adjust where that center of rotation is for the slice. So arbitrary slicing can be really useful for more complex geometries that aren't in clean X, Y, or Z orientations. For this data set, I should be fine just using one of the standard X, Y, or Z slices. So I'm going to press Y and go back to this Y slice to see what the what the density is behind the cylinder. So now that I have a slice cutting through the volume data and I have vector variables that exist in the volume zones, I have an opportunity to show vectors on the slice. So for that, I can right click, and like the cylinder, a zone, we can right click derived objects to make quick plot style changes as well. So I can click here to toggle on the vectors. I'm prompted to provide the vector variables to use. In this case, these look great. If I needed to change them, I can click the drop-down menu and I click OK. And now this slice will update showing the vectors that exist at this intersection in the volume. Now, if I zoom in a little bit, you'll notice that there's more vectors as we get closer to the cylinder, and I can toggle on the mesh for the slice as well, which is derived from the mesh or grid used for the volume zone that it's intersecting. And so because of that, this volume has more precision as we get closer and closer to the cylinder. And the way our vectors are plotted, a vector is plotted for each node. So as it gets more precise, closer to the cylinder, we get more vectors plotted. And because of this, it looks a little bit cluttered. So what we do, or what we can do, is we have the option of using even vector spacing. So for that, I can click this gear icon next to the vector toggle for the zone layer, because this vector details dialog is for all vectors in our plot, or at least for this frame. And from here, I can change the vector variables that are being used. If I do need to adjust that, I can change the vector length to be uniform or to be relative to the magnitude of the variables used. And then I have this option to use even vector spacing. And what this does is it'll plot fewer vectors, and that makes it much easier to see what the flow looks like. And if I zoom back out, it'll adjust based on the current view that I have, or I can adjust it quantitatively by entering a specific spacing value if I want to. All right, so the next thing I can do with the slices, maybe I want to adjust this slice a little bit more, and I have a details button, this gear icon, to adjust the slice as it is now. So what I can do is I can use the slider to adjust the slice rather than using the slice placement tool. I can specify a specific value. Maybe I want to zero this slice at a specific location. I can show start and end slices rather than just showing one slice at a time. And if I want to have multiple different slice groups, I have the option, just like having multiple contour groups, by selecting one of the numbers here. And maybe I want to have a slice in the x-planes direction intersecting the other way. So what I could do for this is I could show start and end slices. Maybe I want it just in front of the cylinder and then one just behind. And then I can also add an intermediate slice. So this is a quick way to add multiple slices intersecting in our data set without having to add too many new slice groups. And then just below this, I have this option for changing what we are slicing through. So I can slice through surface zones, which would be intersecting the surface, the cylinder surface, or surfaces of volume zones. So you can see this looks similar to showing the edge of the volume zones that I showed earlier. But in this case, the volume zone slice is going to be the most useful for this data set. So I'll leave it as is for now. So I'm going to come back to the second slice group once I show some data extraction, which will be this button at the bottom here. But for now, because of the way the slices are placed, they're kind of obscuring the other Y slice that I want to use. And so I'm going to toggle this off for now so that they're not visible, but I can easily come back to this later on. All right, the next derived object I want to show is the Isosurface tool. And for that, I want to get a little more information about the data set. So the slice tool intersects at a specific point in one direction, whereas Isosurfaces allow us to plot using one of the contour groups in our data set to plot a 3D surface at a specific variable value. So for that, let's say I'm interested in what is happening at some of these lower density values. So I can probe close to here if that's a region that looks good, right here. I can right click to copy from the probe sidebar. I could open up this Isosurfaces details dialog. And as you can see, this drop down has selected the first contour group, which is the same as the contour variable that we are showing on the slice. And I can paste that value that I copied from the plot sidebar in order to plot the isosurface at that point. And then when I toggle on Isosurfaces, we'll get that 3D shape indicating where that specific value of density is. And now if I zoom back out, we can see the full length of the length of the or the height of the cylinder and where that density value is just behind it. And now if I reset my animation, we can see not only how the density changes and how the vectors change following the cylinder over time, but we can see what the density value is, or see where that density value is over time. Now, because it's an isosurface, it's obscuring a bit of the slice here. So I have the option of right-clicking and using this translucency for the isosurface. So I can still see the vectors that are close to the cylinder without obscuring too much of the shape of the isosurface. All right, the next derived object I want to show is the stream trace tool. And for this, I will click this stream trace placement tool, which can also be found up in the data toolbar here. And if I left click here, this creates a volume line stream trace. If I single click, I can click and drag to create a rake of stream traces, the default of which is 10. And if I want to change that, I can click this gear icon to open up the stream trace details dialog, and I can adjust the number. Maybe I want to reduce the number of seed points that are being created. Now I'm only seeding 5 stream traces per point. From this drop-down menu, I can see several different options for creating stream traces. Surface line, if I wanted to seed them along a zone surface. Volume line, which is what I had just been showing. Volume ribbon, which is a 2D stream trace. Volume rod, which is a 3D stream trace, the default of which is 3 connecting points. And if I want to change that, I can go to the rod and ribbon tab to adjust the number of points. I can also change the coloring used for the rod and ribbon to make them stand out a little bit more. And I can do the same thing with the stream trace volume lines as well. So let's say I want to use the volume rod. Here we go. Let me actually need to seed it there. There's the volume rod. And maybe I want to show only volume rod. So I can quickly delete all the stream traces that I just shown, click and drag. Now I get a much cleaner looking plot, or more consistent style-wise plot showing the volume rod stream traces to indicate the flow. All right, just below the derived object toggles, we have the effects toggles. And so this allows us to turn on and off lighting. You'll notice this is only affecting the cylinder. This isn't affecting the slices as they are now. there it is. Now we can see it affecting the isosurface and the slices. If I adjust the light source, it changes the direction the light source is coming from. I can click this gear icon to add more details for the light source as well. I can toggle on translucency. You'll see this is only affecting the cylinder. To change the translucency for each of the derived objects like slices or isosurfaces, that can be found in the details dialog for each of those. So if I go to the contour tab for slices, I can turn on translucency, or I can also use the right-click context menu to turn that on and off or adjust it as needed as well. There we go. All right, so that's a quick overview of what the tools we have available to us to change the visual style of our plot. Next, I'm going to go into more analysis of our data set and do some variable calculation and data extraction. So for that, I'll go to this Analyze drop-down menu. And this menu is split into two sections. The top section is to define the settings for any of the calculations that we make. And then the bottom section is all the different calculations available to us. So we have calculate variables, perform integration, and then we also have this calculate particle paths and streak lines. And this is useful for a transient data set like this, where we are wanting to plot stream traces to create a more or get a more accurate representation of the physics using our stream traces. So I'm not going to use it for this demonstration, but that is important to point out for a transient data set where you are wanting to plot stream traces or something similar. So the first thing I want to show for this is calculating a new variable. But before I do that, I want to point out one of the dialogues that has to be completed before the variable calculation. So this is the field variables dialog. And for this data set, they've already been assigned correctly as loaded in. But this is important to check if you have a data set where you have not already assigned them. Your convective variables and then your state variables from several different options in order to complete the variable calculation. All right. So next I'll go to Analyze, Calculate Variables, and from here I can click Select, and we have a list of quite a few different variables that can be calculated. These are predefined equations, and for this what I want to do, let me make sure I didn't lose it. I want to calculate, because there's so many I'm going to track, there we go. I want to calculate the kinetic energy using the existing variables in our data set. So I'll click OK, and then I'll click Calculate. And we get this menu saying calculate on demand was successfully set up. And that's what this toggle here is. So what this means, if I go to Dataset Info to see, we have this new variable that's kinetic energy, but you'll see the variable status is not loaded. And that's because calculate on demand will set up the equation for the variable, but it won't complete the calculation and load the variable until some specific plot element demands it. So for that, we need to add it to the plot in some way, and then the variable will be loaded. So what I want to do is I'm going to go to the isosurfaces, and just to make this a little easier to see, I'm going to turn off translucency for now. But for this, what I want to do is I want to define an isosurface at using that kinetic energy variable, but rather than interrupting the rest of the visual style that the slices and the contour on the surface that already uses density, I'm going to select a second contour group that the isosurface is defined by. And then to change what that contour group is, I click this gear icon to open up the details dialog. I can click from this drop down and select this new kinetic energy variable, and then my plot will update. So now I can adjust the isosurface. Maybe I want to know what's happening at a higher kinetic energy value. And then instead of contouring by density, which can get a little confusing, I suppose, let's use the shade, and let's highlight this, or let's use a darker red. There we go. And then once I have it plotted, I can turn back on translucency so it's not obscuring the rest of the plot. All right, so that's one way to calculate a new variable for a data set. Another way is if I go to Data, Alter, Specify Equations, and this allows me to create a new variable using a custom equation that may or may not exist in the Calculate Variables tool. All right, so the next thing I want to show is some data extraction, and for that I'm going to go back to the Slice Details dialog and go back to the second slice group. So I'll turn this back on. So let's say I want to extract these three slices and get an idea of what the flow is like just before and just after the cylinder. As they are now, they're slicing and intersecting through the entire extent of the volume, and that can be first of all, it's a little cumbersome to look around, but also it's a bit much for what we want. Maybe I'm just interested in just the immediate what's directly behind the cylinder. So for that, I'm going to trim down these slices using this capability called value blanking. So I'm going to go to plot, blanking, value blanking, and this allows me to define blanking criteria. So I'm going to blank when y is less than a certain value and when y is greater than a certain value. So I'll activate both of these constraints, and then I'll toggle on value blanking, and that'll trim down these X slices. So I'm just looking at the region of the slice that's directly behind the cylinder. And now that I have those set up the way they are, I can toggle on or off these, the zone blanking specific to each slice group if I want. And then once I have this toggled on and click extract slices, the extracted slices, which will be extracted to new zones, will obey the blanking criteria that I've set up. So I'm going to click extract. Tecplot will start going through each of the time steps because I'm extracting for all solution times, and I'm creating a new zone for each slice. So I'll click close. Actually, what I'll do for the slices is I'll show that if I toggle on and off these slice groups for the second group here, we still have these, make sure that's off. We still have these slices visualized because we have them as newly extracted slice zones. So if I wanted to, I could toggle these on and off from the zone style dialog rather than from the slice tool, because now they're treated as a separate region of data. And then to show this even further, I can go to plot, blanking, value blanking, toggle off value blanking. Those slices will still obey the blanking criteria that was set initially before the extraction was performed. All right, so why did I do this? Now that I've got these slices, one before and then two after the cylinder, what I can use these slices for is for some deeper analysis and using for an integration. Because we can't do the integrations on any of the derived objects, we have to perform extractions on them. Now that they're extracted to zones, we can do analysis on them like we would with any other region in our data set. So if I go to Analyze, Perform Integration, this is the Integrate dialog. You can see we have quite a few different integration options. The one I'm interested for this is the mass flow rate. So I'll select that integration option. I'll change my domain of integration to integrate over time strands, and then I will select the 3 time strands that correspond with those extracted slice zones. So I'll select OK. And then included in the domain of integration is the exclude blanked regions toggle. So this is useful if we do want to use value blanking as part of the constraint for the integration. In this case, it's not necessary because the extracted slices are already trimmed down based on that initial extraction. But that is important to keep in mind if you are wanting to use value blanking for other integrations. I'm going to toggle off show tabulated results and toggle on plot results as, and I'm going to title this mass flow rate. I'm going to click integrate. And then what this creates, this actually creates a new data set and a new XY line plot showing what the mass flow rate is for each of these slices over time. So when I click on this new frame, you can see the plot sidebar updates with the XY line plot type. I can toggle on and off these symbols. If I want to get into more detail, I can go to the mapping style dialog, go to the lines tab, and maybe I want to increase the line thickness. I can change the line pattern if I want these to stand out a little bit more. And then I can go to plot line legend to show a label for each of the lines. So it gives me a label of each of the strands. That's okay, but I want this to show what the slice location is. So I can rename these mapping names as well. So I'm going to rename it to indicate the position of each of those slices. Another thing I can do is you can see the axis title overlaps a little bit just because of how it was generated. I can use the adjuster tool, click the title and drag it. Here we go, drag it off of the numbering. And I can do this for the solution time if I want to do that as well. So those are a couple of the changes we can make to the XY line plot. If we are doing a lot of line plot generation, and we have a similar plot style that we want to reuse over and over again, we have the option of using what we call style sheets. And so what I can do is I can go to Frame, Load Frame Style, and I've already set up one for this demonstration called Mass Flow Style, and this will reset the style for the XY line plot that I used using the conditions that I had set previously. So this is really useful if we have similar types of data and we want to generate the same plot style, and it'll update only the frame that I have loaded the style sheet into. And that's a great way to recreate quick plots, or quickly recreate plot styles that I want to use over and over again. The other thing I can do, there's a bit of overlap with this frame over the other. So what I can do is go to Frame, Tile Frames, and tile them one over the other. And maybe I want to give a little more room to the 3D plot, so I can size this down a bit and adjust that as needed. But now that I have these two frames, I can click this time animation, and because these are linked from the integration, we have this bar indicating what solution time we are at in the XY line plot that corresponds with the view that we're currently looking at in the 3D plot view. There we go. All right, so let's say we're happy with the work we've done so far, but we want to be able to come back to it. We have the option of saving our work in a couple ways. One way is by going to File, Save Layout. I can go to here to show the different layout options available to us. The first one is the linked data layout. And what this will do is it'll save all of our pages, so all of these workspaces, which includes all of the frames on all of the workspaces, to a .lay file that points to the data set that we have been using. So this saves a separate file and it doesn't resave the data. So this is a more lightweight file and a lightweight way to save the work we have been doing. So when we come back to Tecplot 360, we could just open this layout file. It'll point to the data set being used, and we can easily resume our work. The other option is a packaged data layout. And this is a layout file that'll save the layout information, but it will also resave the data set as a Tecplot binary file. And that way, you only have one file that you need to use. And if you have any if you have the need to share your work with your colleagues, or you want to be able to easily transport your data or send your data anywhere, this way you only need to send one file, this one LPK file. So it's a much heavier file because it's resaving the data set, but it can be a little bit easier to work with if you don't want to have to keep track of all kinds of separate data sets. This just makes it easier to keep it all in one place. So that's one way we can save our work. If we want to show off our work that we've done, we can go to File, Export, and this allows us to export in multiple image formats, vector and raster. We can export specific regions of our data set if we want to export just one frame at a time, all frames, or work area, which is everything over this gray workspace. We can use different export width if we want, and use anti-aliasing if we want a crisp and clean looking plot for our export. So that's how we export as an image. If I go back to this time animation details dialog, I pointed out there's this film strip icon. This opens up the export dialog, which looks very similar, but it is for the video animation export options available to us, or exporting as a sequence of images as well. So for the sequence of images, we ship Tecplot 360 with FFmpeg if you want to be able to stitch these together in an animation, and we have a knowledge base article that shows how to do that as well. So this is a more recent addition to Tecplot 360. So whichever format you want to be able to export in, we have a lot of different options available to you. And then the rest of the options here are very similar to what the image export animation will show: anti-aliasing, changing the width, or changing the region of our export. So the animation export is in each dialog where it makes sense. So the time animation details dialog, you may have spotted that it was also in the slice details dialog. We have this film strip icon. So to review which animation options are available to you for your data set, you can click this animate drop-down menu to see all of those. And then for 3D Cartesian plots, we also have this keyframe animation option. And what this allows us to do is we can stitch together multiple different 3D views to create a more a more interesting animation in 3D, adjusting the 3D view of the plot. So this is cool, or cooler to show off your data or to look at if you have a cool 3D plot, but it also gives the option of animating concurrently with time if we have a time or time animation or transient data set like we do in this case. So maybe not for analysis, but this could be useful for creating a slick looking 3D animation that you want to show off to your clients or the rest of your colleagues to show the work you've done in Tecplot 360. All right, well, that concludes what I wanted to demonstrate for today. And so we'll transition into questions. Before I do that though, I will point out that we do have a webinar next month. So on December 7th, we'll have a release webinar for FieldView 21. So as of 2019, FieldView and Tecplot are owned by the same company, that's Vila Software Group. And FieldView brings MPI parallelism, client-server architecture, and high-quality 3D rendering for CFD data to Tecplot's post-processing product suite. So join us on December 7th next month to learn more about the release of FieldView 21, which adds a unique auto partitioner that extends MPI parallel benefits to single grid and poorly balanced multi-grid structured data sets. So you can enter the bit.ly link below to register for the webinar right now. All right, so let's get into some of the questions that may have come up during the webinar. A reminder that if you have questions following this, you can email us at support@tecplot.com or email support-eu@tecplot.com to contact our European office. All right, so let's see what questions have come up.
I have one question. It is about, you showed probing. Can you show how to probe a point over time?
So that is a good question. Let me switch back to the Tecplot 360 dataset to show that. So we do have that option. It is not from the probe sidebar. It is from this tools drop-down menu, and it's this probe to create time series plot. So the cursor changes to something very similar, and I can probe a slice or I can probe a surface, and this will give me the value of that contour variable that's currently active, in this case the row or density, and show what the change looks like over time. And similar to this time strand integration we did, when I hit play, we'll have this bar indicating what the solution time is in this XY line plot because the frames are linked together. So that's a way you can probe at a specific point over time, and that's included in the Tecplot 360 installation under the tools drop-down menu.
Let's say we want to write out our extracted slices, or let's say that that line that we just extracted through time, or that data point through time. How would someone maybe do that?
Yes, so for that, we can go to whichever frame where we want to write out that data set to another file. So for example, we could use this probe over time plot. If I go to File, Write Data, I have the option of exporting in one of our Tecplot binary formats, or we could export as a Tecplot ASCII data file as well if we want it to be legible in some other tool. So that allows us to, if I hit save, I can specify the zones. So in this case, this newly created plot is just a single zone, the time series plot zone. But we could do the same for our 3D plot, where we could export just those slices we extracted, just the cylinder data if we wanted, or any other data extractions that we want. And we can specify which variables we want to export as well, and in which data format. So that's how you could write out data that you've extracted or done analysis on in Tecplot 360 to a different data file.
But how easily will I be able to take data I've collected and transform it into files that Tecplot can read? That's a great question. I'll field that one. There's a lot of different options. We have a ton of different loaders that you can load in various types of CFD data into Tecplot, and then other types of data too. If you find that there's not a loader that you need to load your data into Tecplot, reach out to our support staff. That's support@tecplot.com. and we're happy to help. If you can share your data too, that's also wonderful, and we can do the best we can to load in your data. We have a lot of different workarounds. If, let's say, you just have CSV data, we can create carpet plots if needed with XY data, or we have a lot of different options too. So usually it's a case-by-case basis, so it's really helpful if we can see that data, and we can work with your individual case too with our support staff. All right, we've got a couple more questions that have come in here. So how to alter the stream coordinate x to normalize values like x divided by L, where L is the total length. That's a good question here. So let's say, yeah, what was that, Jared?
Yeah, so something you can do for quick or adjustments to like normalization or unit conversions, you can use the specify equations tool to create a new variable or adjust existing variables. So that's one way you could start to approach that.
Right. Yeah. So in this dialog, what you could do is just create a new variable that normalized x, and then set it equal to our x variable, and then divide it by L, that total length that you're wanting to normalize by. Okay. And then, is there a way to read binary files when the text file becomes larger? That's a good question. So we have if you're working with Tecplot data, our .plt files are binary format. But let's say you start with .ascii Tecplot file format first. So you could load that into Tecplot just easily, or you could convert it on the command line before you get to the GUI. We have a executable that can convert your ASCII files to binary, so you don't have to wait in the GUI to load in that data. So great question. We highly recommend transforming your ASCII files into binary format if you can, and we have a number of different tools that can do that. And if you have any troubles, our support staff is happy to help.
Yeah, the name of the utility that converts ASCII to binary is called preplot, and that's included in the Tecplot 360 installation. So that it'll be included with your Tecplot 360 install, and if you have questions about using that, you can contact us, and there's good info in the Tecplot 360 users manual as well.
Great. And then we have another question here. Can Tecplot read .h5 files from ANSYS 20? Yes, so we have implemented a loader that for the newer ANSYS Fluent files, that loads those .cas h5 and .dat h5 file formats. Okay, those are the extent of the questions that I see so far.
Yeah, we've got a couple minutes left, so we can stay on for a little bit longer. So keep sending in questions if you do have them. And again, if you do have questions following, email support@tecplot.com. There we go. I'll go back to this page so people can see the emails for our office and our European office support email as well.
Okay, I don't see any further questions coming in at this time.
All right. If there's no more coming in, again, email us if you do have questions following this, and we'll be posting the recording for this as well if you want to review later and try recreating on your own as well.
All right, Jared, real quick, we do have one more that just came in here. So what is the learning curve like? So are there online tutorials and getting started documents for people to use to get started with Tecplot 360?
Yes, so you can see from the page we have here, we have a collection of tutorial videos at our website, tecplot.com/videos, but then also included in the installation. If if I go and toggle back on this welcome screen, which you see for the first time when you start Tecplot 360, we have a getting started guide that is included as documentation with the Tecplot 360 install. So the dataset that I'm using in this getting started guide on page 8, it links to where you can download these example files as well. But this is a great place to get started, as the name implies, using Tecplot 360. We have those tutorial videos that I was talking about, and then we also have our technical support team if you have specific questions that you need answers for your data.
Yeah, just a remark from me, Jens. Europe, we offer very often for our customers training, so just contact us if you're on the European area. I think it's the same for the USA, but I speak for Europe. Just contact us and ask for a free training for your group, and we will see what we can do. And that's an option for your team.
Yes, thank you, Jens. Yeah, that's something we offer as well. If you have, especially given the nature of how complicated some of your work may be using Tecplot 360, you may have specific needs that you want addressed and specific questions you want answered. So we offer those free trainings as well to help you get started using Tecplot 360.
Okay, that looks like that's still the last question.
All right. Well, again, if you have questions following, let us know. support@tecplot.com, support-eu@tecplot.com, and we'll be happy to address those. But for now, I'll close the webinar, and thank you again for joining us, and we hope to have you again next time.